This video is about the properties of midsegments and midtriangles and the properties of perpendicular bisectors. We're going to start by looking at midsegments and midtriangles. So a midsegment of a triangle is a segment that joins midpoints of two sides of a triangle. The midsegment is parallel to the third side of the triangle. Every triangle is always going to have three midsegments, which are going to form your mid-triangle. So in the image below, one of our midsegments is DE. DE is parallel to AC, and it bisects the sides AB because D is a midpoint, and BC because E is a midpoint. Another midsegment that we have is EF. EF is parallel to the side AB, and it helps to bisect BC because it has the E midpoint, and AC because F is the midpoint of that side. The last midsegment we have is DF, which is parallel to its third side BC, and it connects the midpoints of AB and AC. Those three segments together form their own triangle inside the larger triangle. This triangle that they form is called the mid-triangle. Our name of our mid-triangle then in this case would be triangle DEF. It's also important to remember that a mid-segment, two of those is equal to the length of its base. So we're going to use that idea to solve for a variable. So in number one, JM is a midsegment. So we need two lengths of JM to equal the length of KL. So we're going to do 2 times 2x plus 4 is equal to 32. So first I'm going to distribute 4x plus 8 equals 32. Then to get x by itself, I'm going to subtract 8 on both sides, so 4x is equal to 24, and divide by 4, so x is equal to 6. The same thing in number 2 when our triangle is turned a little bit. So now we have midsegment BE. So we need 2 times the length of BE is equal to the length of my base, which is CD. So I'm going to do 2 times 5x minus 2 is equal to 8x plus 4. So my first step is to distribute. 10x minus 4 equals 8x plus 4. I need to get my variable to one side and my constant to the other. So I'm going to subtract 8x to get 2x, and I'm going to add the negative 4 to get 8. So we have 2x equals 8, and we divide by 2. X is equal to 4. In number 3, ABC is a triangle with mid-triangle DEF. Find the perimeter of the triangle and the mid-triangle. So let's start by looking at the mid-segment with a length of 5. Remember that the mid-segment, we need 2 of those to equal the length of our base, which means that AC, the base, has a length of 10, and that side is bisected into 5 and 5. The other midsegment that we are given is 9. So it's across from the BC side, so I double that to get my measure is 18. That side is also bisected into 9 and 9. Working backwards in the other one, they're giving us that each piece of AB is 6. So 6 plus 6 is 12 for my length of my base. Half of 12 gets me my other midsegment then, which is 6. So we need to find the perimeter. Perimeter is when we add our sides together. So the perimeter of ABC, we're going to add the sides 12 plus 18 plus 10. We get a perimeter of 40. My perimeter of triangle DEF With my perimeter, I'm going to add the sides 5, 6, and 9. And we get a perimeter of 20. This should make sense that the perimeter of our mid-triangle is half the perimeter of the bigger triangle because my mid-segments have half the length of my base sides. Now let's look at the angles of a mid-segment triangle. So triangle ENT is a mid-triangle. Complete the chart listing all angles that have the following measures. So 50 degrees, 60 degrees, and 70 degrees. Those are the three angles we're going to work with because this triangle has to equal 180 and it has all three angles already. So all other triangles are going to have those same exact measures. The thing to remember is that all of our mid-segments are parallel to the base that they are running the same direction as. So NT is parallel to AP, EN is parallel to PU, and ET is parallel to AU. So using this idea, I'm going to pick two of my parallel sides. So I'm going to pick AP and NT. If I pick the side that has angles along with it, this will be my transversal. So I can use alternate interior angles to fill in the measure of two angles. 50, actually I'm not going to use 50 yet, we're going to use 70 first. So 70 is an alternate interior angle, and I can fill in 70 degrees there. Another thing that we can do is we can use EN and PU. AP will serve as my transversal, which means that's 60 degrees, and the angle right here by E are corresponding angles, which means they have the same measure. Then just changing one of my lines back to NT, I can use alternate interior angles again. So if 60 degrees is here, it's also on the inside of this triangle. Now that helps me because in this triangle, I now have a straight line left over. So the missing angle in this triangle, if a straight line is 180 degrees, and I know that my two angles are 60 and 70, my third angle has to be 50 degrees. Then let's switch parallel lines again. So let's switch to AU and ET. If I pick EN as my transversal, I have alternate interior angles with 50 degrees. So 50 degrees is right there. Now I can fill in the remaining angles of my triangle. Up in the top triangle, EAN, I have a 50 and a 60, so I know that my top angle has to be 70 degrees. Also, looking over here at AU, it's a straight line, so if I have a 50, a 60, this must be 70 degrees. Over by T, it's a straight angle with these three angles, so 50, 70, my missing angle is 60 degrees. And then the remaining angle of the triangle has to equal 180, so if I have 70 and 60, this angle is 50 degrees. So my 50 degree angles are given to me as PTE. Another 50 degree angle is NET. Another angle in the top triangle is ANE. And my last 50 degree angle is down in the bottom corner, NUT. My 60 degree angles, one of them given to me is EPT. I also know I have an angle AEN that's 60 degrees. Angle ENT in the middle triangle, and angle NTU. My 70 degree angles are angle EAN, angle NTE, and angle TNU. The thing to notice about the angles in a triangle is that the triangles on the outside touching the mid-segment triangle all have angles in the same positions. The 70 is always on top, The 60 was always on the bottom left, and the 50 was always on the bottom right. Then in my mid-segment triangle, I can just figure out what angle is missing from each intersection to fill in my angles. The last thing we're going to talk about is a perpendicular bisector. You've seen both of these happen before separate. Now we're going to put it together. A perpendicular bisector then has two roles. It's going to, at the intersection, form right angles. So at B, there's two right angles. It's also going to divide the intersected segment into two congruent parts. So AC is bisected into two congruent parts, AB and BC. So let's use this to solve for X and Y. In number 5, AB is a perpendicular bisector. So when I look at AB, I know that I have right angles and my side is bisected. So my two equations I'm going to set up for my angle is 12x minus 6 equals 90. And for my sides, 4x plus 3 equals 6x minus 9. Now, this equation with the 12x has one variable, so we're going to solve it first. We're going to add 6 to both sides, so 12x equals 96, and divide by 12, so x is equal to 8. Once I know x is 8, I can substitute 8 in for x in my other equation. So when I substitute 4 times 8 plus 3 equals 6 times 8 minus y. So we get 35 is equal to 48 minus y. I'm going to subtract 48 from both sides. Negative 13 is equal to negative y, which means that y is equal to 13 when I divide by negative 1. The same thing happens in number 6. AB is a perpendicular bisector again. So we have right angles, and my sides are bisected. So I can set up two equations. My first equation, 5x plus 10y is equal to 90 for the right angle, and then my bisected sides, 3x plus 7y is equal to 58. So I'm going to use elimination. I need to multiply both my equations. So I'm going to eliminate x. So I multiply my first equation by 3, my second equation by negative 5. So we get 15x plus 30y is equal to 270, and negative 15x minus 35y is equal to negative 290. So when I add, my x's cancel out. I'm left with negative 5y equals negative 20. Divide by negative 5, y is 4. Once I know that y is 4, I have to substitute into one of my equations. So I'm going to pick the first equation. 5x plus 10 times 4 equals 90. 5x plus 40 equals 90. 5x equals to 50. So when I divide, I get that x equals 10. So my solution here would be 10, 4.